Hi everyone, Sonu here. Today I'm going to talk about one of the burning topic in backend development is API optimization. And this I'm going to share you some of the pointer. And this pointer is relevant while building a new API as well. And also if you are optimizing any existing API, most of the time your API is written 5 years back, 2 year back, right? And many time like developer keep adding the code on top of your existing code, so this your number of code line is also increased in a particular API, and this impact your response time. So now I'm going to share you my practical tips which I usually use while optimizing or while reviewing any API. uh, I'll talk about all the pointer one by one. Okay, so first pointer which you should see is database query. In some most of the case, like database query is one of the problematic things in API response time. Three things you can consider while reviewing your database query. One, you can check is there any redundant database query. For examples, maybe there are 3 4 places where you are calling same database same table to get a data, because there are multiple developer who is contributing to you, this API. So they there will be a scenario developer has not checked previous database query and simply just added one more service function or util function to get a new data. So you can remove redundant database query. That is point number one. Point number two is you can review the index. If your API database response is taking more time, you can review the index. Maybe you don't have proper index. So there are multiple way to review your index, like describe methods or function are there in a database that will help you to understand your complexity of your database query, right? So these things you can improve. Third pointer is like you can optimize your join query. Most of the case, this is also one of the things which you can check while reviewing a database query in any API. Second pointer is cache. Cache is also a very uh, important things while building any API or optimizing the API. But you need to understand why do you really need a cache, that you need to think of. Okay, so for example, if there is any create API, you can't add cache. I mean, there is no required. If there is any get API and you are taking data from a table which is very frequently changing, in that case, of course, cache will not work, right? Because your data is keep refreshing, right? So that will not work. Second thing is, do you really want to cache all the response, or you want to cache some of the things like maybe ranking of the content, those kind of things? Because let's say you have algorithm which keep updating a ranking of your content on every 30 minutes, let's say, and those kind of things you can cache, right? Because this is not frequently changing, right? So if your content is not frequently changing, you can add some sort of cache there. Okay, and you can cache also particular component basically means maybe you can cache function response or something like that. So cache decision is also one of the critical things while optimizing any API. Third point is adding a queue. This point is also one of the important things, because you need to decide which component can be added in a queue. So I can tell you two simple example which will help you to take a decision on queue. For example, after a sign up, you need to send an email. Email can be added in a queue. It's a simple example actually, by the way. Second example I can give you. Let's say you have a API, post API, and in that API you need to call third party, let's say plugin or third party API, let's say, within that API. And because this API is now you are doing IO intensive work, right? You need to understand either you are doing IO intensive work or you are doing compute intensive work. IO intensive work is like you are doing some sort of API call, you are doing database query, you are doing some sort of email, you are sending email, SMS, or other things, right? Those kind of things you can put, let's say you want a response also in that API, and then only you want to reply to the user. That also you can do, but you can put IO intensive work in async. So your OS will optimize that query, and there will be a parallel execution, and you will get you can easily complete this API cycle. Okay, so this queue decision is also very important while building any API. Okay, socket. Maybe you will be surprised, like why I'm talking about socket in this topic. Okay, socket is important because see, while optimizing a API, it's not always you can optimize from backend. So, for example, if it is a there is a Twitter thread, okay, in Twitter, any post detail you are getting a counter like, and that is very frequent. Like this is changing every millisecond, something like that, right? Do you think that is possible through API? Right? So you need to design your API in such a way like you can put all these kind of things in a socket, and you can ask your front end team to connect to socket and get the updated count or get the updated like, those kind of things. So you need to design your API very well. You need to also leverage socket whenever you require, right? Fourth thing is fifth point is reduce the payload. This is also important because if you are returning whole table or you are returning lots of data, ultimately your data will travel through internet, right? So your packet size, your payload size will impact your API performance. So you can reduce, you can add proper project I'm talking about, like if you are doing a mango query, so you don't need to add a proper project. So you only take a relevant column which is required in your API. You don't need to simply dump all the table to the front end, right? So those kind of things you need to do. Payload is also very, very important. Okay. Now, okay, so you have checked your code. Now almost you have optimized your code. Still you are facing issue, and this is now you need to see like where is the problem, right? Problem can be in your code deployment. So now it's time to check your DevOps. Go to your virtual machine. If you have deployed on virtual machine, go there, check the CPU and memory utilization. If you are deployed on Kubernetes, check CPU and memory utilization. CPU utilization will tell you if you have added any bad code. So, for example, you have added any computation heavy code. You have added, for example, you have done some sort of query in recursion and you forget to close or add any break statement. So those kind of things going to impact your CPU. Okay, so you can go and you can optimize, and because of other API also, this will impact your this API. It's not like if CPU optimization is going to high just because of, let's say, API B, this is going to impact your API because ultimately one CPU is serving your all both API, right? That is one thing. Second thing is you can check memory utilization. So let's say you have you are doing your CPU, your server is not capable to handle the load, right? So ideally in any production, you should consider CPU and memory utilization should not be more than 40%. If you are checking, if you are seeing any kind of spike in, so in case of CPU utilization, of course you need to check your code. In case of memory utilization, you need to check, you need to add proper load balancing there because you are getting lots of load and your server is not able to handle that traffic. Okay, so you need to think about proper load balancing. Maybe you need to increase number of server there. One of the easiest way to scale here is like horizontal scaling. You can add kind of horizontal scaling because this is easy, and this is more scalable, because if you do the vertical scale, then you have to stop, then you have to scale, then again you have to run the server. This is usually no one prefer, until unless you have some of the case where you actually need a vertical scaling. For example, you are running some ML on your server, and your server is not capable to run that model. Okay, so basically, let's assume your model size, pickle file is size is large, then you have to do a vertical scaling, right? So that depends on scenario. Most of the case, it's a horizontal scaling. So you have to keep adding the number of server. Depends on the load. Next point is check your DB. Even if your server is doing good, you have optimized your code, there will be a chance your response time is not good, because maybe your DB is not capable to take that kind of request. Let's say you got millions of it, right? And your database is deployed in a server which is not capable to take that much read write request. So you can't. I mean, uh, this is going to impact your response time basically. Okay, how you can check this? So go to your database. Either you have hosted in your virtual machine, or you have used any third party provider. Then you have to go there. You have to see again CPU utilization, memory utilization. You can check how, which query is impacting your database. It might maybe some of the another database query, which may be most of in some case, like you are doing some sort of cron job in a night or early morning, and that there you are doing some sort of very heavy database query related to kind of model data export. Although in production no one use direct database query for this kind of data pipeline, but still you need to run some sort of batch process to add data from your main database to secondary database. Usually people use secondary database for any kind of data pipeline or machine learning pipelines things. Okay, so database is very critical. You need to increase or you need to scale your database, right? uh, and most if you are using any self cloud managed database, then you can easily scale it, right? In case of your own database, then you have to again, if you have hosted your database in your own virtual machine, then you have to keep adding the, you need to implement an application. Those are the concept, right? When you go for this kind of detail, you will understand this. You need to keep adding the server there, that like if you need a multiple application, that you can do that. Okay, so this is point number 7. Point number 8 is pagination and filter. This is a quick thing. This is related to your API automation. You can add some sort of pagination there. For example, I'm giving you one example. So let's assume you have a dashboard, complex dashboard in a your in your portal. Let's assume. So in that particular dashboard, you have, let's say, 4 or 5 graphs. One way is you can call one API and you can get a data of all 4 graphs. Second way is you can create a multiple API. You can add a loader on all graph, and let's say you call 4 API. When you get the response, you can show 4 loader there, right? So those kind of things you can consider, right? It's not always you can optimize things from backend. There are a scenario when you have to think about optimizing things from front end. Let's say you are creating a kind of business report. There you need a data from multiple tables, right? So either you can add some sort of cache there, or you can, in mostly in this kind of scenario, your user is your manager or your product manager, your internal team, right? So they can wait, right? And there is no for them waiting for 2 seconds is it's not painful, right? Until unless you are showing this to user, uh, otherwise like it's okay. Even if you go to the Google Analytics, they have 30 minutes of delays, right? So those kind of things you can add there. Maybe you can simply add the notes on top. this dashboard is 30-minute delay. It's okay. I mean, you have to think about it. It's not. I mean, there are multiple ways. You need to consider all these those kind of things. Okay. Nine number one point is connection pooling. This is something which sometimes you miss. Connection pooling data. This is related to database connection pooling, and this is very important also. Even if you have good database, you have optimized your query. If you have not managed your connection pool properly, this is your database performance, your query performance will not improve. So this is also one of the important things. I think I have covered 9 points. I'm going to repeat one by one. First thing is database query. Second thing is cache. Third thing is queue. Fourth thing is socket. Fifth point is reduce per payload. Sixth point is check CPU and memory utilization of your machine. It's related to DevOps. Fifth point is check your database DevOps. Like check your database performance. Eighth number point is pagination and filter that you can add. I have given you some of the example. Maybe that will give you a good idea about it. Nine number point is connection pooling. I'm 100% sure I have missed some of the pointer here, but if you go through this 9 point, I you in most of the case, like you will be able to solve this API response time problem. Uh, Feel free to drop me a message if you have anything. If you want any other things related to backend, uh, please let me know. Next time, I'm planning to create a video on app security. Let's stay tuned. I hope you like this video. Please subscribe to my channel so I can get sort of motivation to make video like this. I'm also planning to add some of my colleague who is working in a good startup and they are leading their team. So please subscribe. Thank you.